Alright, welcome back to part 4 of our calculus series. This is the second to last video I'll be making. Today we're going to talk about integrals, and we're going to talk about them in the context of being an antiderivative. So, as an antiderivative, what I mean is the integral is the opposite of a derivative. So this is a pretty big part of understanding this. So we're going to bring back a notation that I mentioned in the derivatives video. So there's going to be dx of the integral of f of x equals f of x. Now let me make this like not 2-point font. Alright. Oh, yeah, that's why it's weird. Okay, one sec. I goofed up. Alright. Now we should be good. To insert our integral. Yeah, there we go. F of x equals f of x. Now what does this mean? This means that our derivative and our integral are opposites. Alright? So this means if I want to say, alright, let's take the derivative of some function f of x. Alright, this is going to be equal to f prime of x, as we talked about before. Alright, so right now we have this. Alright, now what we can say is we can say that the integral of this f prime of x equals f of x. So our integral is our antiderivative, and generally we notate it as we'll put the integral of little f of x equals big F of x. Alright, and this is going to be our antiderivative. Now, let's do some examples here. Oh, what did I just do? Okay, let's do some examples here. And just basic integrals. So, what we're going to do here is we're going to take the integral. We're going to take the integral of we're going to take the integral of, not square root. We're going to take the integral of x squared dx. Now there's always going to be the dx there. I might want to put that on all of these. Now, oh yeah, fundamental part of this is that, sorry about this. A fundamental part of this is that you're always going to have a plus c at the end of all these. Now, why? Why are we always going to have this plus c? So we're always going to have this plus c because if you recall from the last video, the derivative of any constant is going to be 0. Okay, so when we add this plus c, here, when you take the derivative of this c, since we're trying to find when you take the derivative, you get this, right? If we have this plus c, no matter what this constant is, this will always be the same. All right, so basically, we're just going to want to put that on there for now. We won't need it later once we get into integrals as area, but for now we will. So we're going to take the integral of x squared dx. Now this is going to be reverse power rule. All right, now reverse power rule is going to be reverse power rule of we'll say x to the n dx is going to be equal to, now this is going to be equal to equal to x to the n plus 1 over n plus 1. Because if you recall, when we take the derivative, we multiply by the exponent and lower it by 1. So here we're adding and dividing by the old exponent. So this is going to get us our value. So back to this problem up here, what we're going to do is the integral of x squared dx, all right, this is just going to be x cubed, because we're going to raise that exponent, but we have to divide it by that exponent. So it's going to be x cubed over 3. Now, if you think about it, this makes sense, because when you take the derivative of x cubed over 3, right, it's going to be what? It's going to be 3x squared. 3x squared. It's going to be 3x squared over 3, and the 3's are going to divide out. So we're going to be left with x squared. So that's the logic behind that. The rest of this is memorization. All right, so if I'm going to give you, for example, I'm going to give you the integral of cosine of x dx. Now, you got to remember that this integral, the derivative of sine of x is cosine x. So this is just going to be sine of x plus c. Plus c. You got to remember that plus c. All right, so this is going to be our basis of the antiderivative, a lot of this stuff. However, we're going to have some weird stuff now. All right, so we're going to do a reverse chain rule problem here. This is a little bit different. So we're going to have the integral of sine of 3x. All right, now what's special about this? What's special about this problem? What's special is that when you take the derivative of this, since it's going from cosine to negative sine, as we know from our derivatives, it's going to be multiplied by that negative and the 3 from the inside with the chain rule. All right, so there should be a negative 3 out front for us to make it cosine of 3x. So how can we make this equivalent? How can we make this equivalent? What we can do is we can multiply the outside by the reciprocal of that. So we're going to have a negative 1 over 3 times a negative 3 on the inside, because these, when multiplied, would just be 1. Okay? So now we can take the clean integral and say this is going to be cosine of 3x, but it's going to be negative cosine 3x over 3. Negative cosine of 3x over 3. And then, can't forget the most important part, plus c. All right, so I'm going to give one more example of this because this can be a little tricky to grasp. All right, let's take the integral of x plus 2. Let's take the integral of this. Poop. The integral of this squared. All right, now let's think about this analytically. So you have this 2 here, meaning that the exponent was a 3. So you would have a multiplied 3 in the front. The derivative of this inside is 1, so that doesn't matter. So we're missing a 3 out front. So what we need to do is we need to multiply this by 1 over 3, make this 3, then we can say this equals x plus 2 cubed, and then we'll multiply by that outside, and that is over 3. All right, so this is going to be the basic, reverse chain rule. Now, this is where it gets fun. So we're going to get to integration by parts. All right, so for integration by parts, So what we're going to have is we're going to have, for example, a product. We're going to have a product. So let me give an example here. We're going to take the integral. We're going to take the integral of 2x e, not 3, e to the negative x. Alright, so before we can really start this, we need to establish what we're going to do. Alright, so there's an acronym. There's an acronym that we're going to be using. Alright, that is LIATE. Right, and this is going to be logs, inverse trig functions, algebraic functions, trig functions. So this is going to be your standard sine, cosine, and then exponentials. Exponentials. Now, all right, what we're going to use this for is to determine our u and v. So the formula, when integrating by parts, this is in the hope that it will turn into something a little more usable, right? So we're going to have uv minus, not a capital, oh, got to put this in equation form. All right, we're going to have uv minus the integral of v du. All right. Now, what does this mean? All right. So our u is going to be the first function we find in this LIATE. All right. So here we're going to have algebraic and exponential. All right. So we're going to have our algebraic and exponential. So our u is going to be our algebraic. Our u is going to be 2x. U is going to be 2x. U is 2x. All right, now our other part is going to be our dv. It's going to be our dv. So our dv is going to be equal to e to the negative x. E to the negative x. E to the negative. So now what we want to find is du and v as well. So you can find that by simple integration, differentiation. Du is going to be 2. And our v, now we need to analyze this with reverse chain rule. So there should be a negative, because when you take the derivative. So this is going to be a negative e to the negative x. Negative e to the negative x. Because when you take the derivative, you're going to multiply by -1, and that's going to be positive. All right, now we can substitute these into the formula. All right, so what we're going to do here is we're going to have uv, so that's going to be negative 2x e to the negative x. 2x e to the negative x. And then minus the indefinite integral. The indefinite integral of v du. So that's going to be negative 2 e to the negative x e to the negative x dx. Alright, so we take our du from here and multiply that by our v. Alright, now we can evaluate this a little bit better. Alright, so we already have our negative 2x e to the negative x. Alright, that's alright. Now, what we're going to put here is we're going to evaluate this integral right here. So when we take the derivative of e to the negative x, it's going to be a -1. Alright, but here we have a 2. Alright, so let's remove this 2, okay, and then we're going to be left with, 2 negative e to the negative x. Negative x. So now keep in mind this is all going to be negative. It's all going to be negative because this right there. So now what we're going to do is this is going to be e to the negative x. So it's going to be negative 2e to the negative x. All right. So we're going to hit enter here. And we're going to have the integral as negative 2x e to the negative x. And we're going to have minus 2 e to the negative x. All right, so now to be sure of this, all right, we're going to take the derivative. We can check this. Oh, and there's going to be a plus c. Sorry about that. All right, so now what we're going to do is we're going to take the derivative to check our work. All right, now for the first part, we're going to use product rule. All right, so we're going to have negative 2 e to the negative x. So first times or second times derivative of the first. Then we're going to have 2x. Then we're going to have 2x because this is going to be multiplied by negative for this. And we're going to have e to the negative x. And then we're going to have a. Alright, and then we're going to subtract the derivative of 2e to the negative x. So we're going to have two negatives, which is going to make a positive 2e to the negative x. Now these two will add, and the c will be 0. And now, since these two add together, we are going to be left with 2x e to the negative x. And there is going to be our integral. It's going to be our integral by parts. This is a tricky concept, but you should get it pretty soon.